Hello everyone, November the 7th. Let's get right into it. Determine if a cell is reachable at a given time. I'm going to switch to Java. One day, but not today. Alright, I give 4 integers and a non-negative integer t, 1, 2, 3, 4, 5. In an infinite 2D grid, you start at the cell SXSY. The cell SXSY. Each second you must move to any of its adjacent cells. Return true if you can reach cell FXFY after exactly t seconds, or false otherwise. A cell's adjacents are the 8 cells around it that share at least one corner with it. You can visit the same cell several times. So basically we just want to see if we can reach, well, I mean the fastest way is the Manhattan, right? The Manhattan distance, I think, is the fastest way to get there, which means if the time requirement is, actually that's not true because it's 8, so you can actually do diagonal. That might be, I just want to say we'll go 1 2 1 2 3 4 5 6 7 8. We'll take 8, but we can take a shortcut. Every time you do this you reduce 2, right? So if we do, we can use the Manhattan distance as the baseline. So the baseline is 8. If the required time is more than 8, then we can always waste time. We can do like go here, then go here. Whereas if, let's say if t is 8, then you do, if t is 9, then we can say 1 2 3 4 5 6 7 8 9, right? We can always, there's waste 1, this will be waste 2, 8 9 10, right? Or 8 9 7 8 9 10. So doesn't really matter like how you want it to do. If the t is larger, then the Manhattan distance is always going to be true. Now if the t is smaller, that might be interesting, right? That might be interesting. Then each diagonal we take reduce, because if we reach here, right, 1 2 3 4 5, but 1 2 3 4, so we can reduce 1, right? Reduce 1. So we say 1, so this, we need to reduce 2, so we need to do 2 diagonals, right? 2 diagonals. And can we do, let's say 5? Now we need to do 3 diagonals, right? So basically 1 2 3 4 5. Can we do 4? If 4, we need to do 4 diagonals, but at most we can do 1 2 3. 3 diagonals is the most we can do, so we cannot do 4, no matter how, right? Because that's 1 2 3. That's the fastest way, right, to get is, so you calculate how many you calculate the minimum time, right? So as long as t is larger or equal to the minimum time, it shall work. So here is how I would approach it, by saying it can be anywhere. So all we need to do is to find out how many diagonals can we do. So the number of diagonals we can do, number of diagonals we can do, and then what? And then So if it's this, right, then it's going to be, yeah, let's just write it down just so we don't mess up. So we can have started here, right, and final is here. We can have start is here, final is here, right? What else can we do? We can have start is here, final is here. Or, right, we can have this, or start is start is here, final is here, right? So in all these situations, so the shortest distance, right? The shortest distance is we try to, or go diagonal. Right, so diagonal, I might get, yeah, it is just to find the shortest distance between these two. But how do we find the shortest distance? I mean, if it's very narrow, yeah, so we just go diagonal down, see how much we can go, right? And we'll hit a limit. Once we hit a limit, and the remaining is just from this, just go straight down. I think that's the fastest way, right? That's the fastest way. So for this one is the same, right? So it's diagonal. So we have Sx, Sy, oh my god. So diagonal, in this case, so basically it's the Sx minus Fx is right, it's this, and then Sy minus Fy is this. So we take the minimum of this two. So in this case is going to be it's 3, right? 3. So that's the minimum. 1, 2, 3. That's the minimum you can go, right? And then once you get that, plus the difference between the two, right? The difference between those. This is 1, 2, 3, 4, 5 minus 3, so 2. So go 1, 2, 3 minus 2. So plus Sx minus Fx minus Sy minus Fy. I think that is the minimum you can do. So we can say int min steps math.abs yeah, we can say Sx minus Fx math.min of this y minus Fy plus Sx minus Fx Sy minus Fy. That's the min steps. So we return t larger equal to min steps. Okay, gives it a shot. Looks good. We got it wrong. All right, maybe it's not that easy. Pass a lot. Okay, what the hell is this? 1 2 1 2 1. Oh Jesus! Hold a second. So 1 2 1 2. So 1 1 2 0 1 0 1 2. So that's S. Oh, F. Wow. That is. They're on the same spot. If they're on the same spot, I would take them 0. Right? Min step is 0. Huh. So we cannot do exactly. Yeah, that's the key word. Has to be exactly. Because you start, you're already there, so you take 0 steps. But if as long as you need to take 1 step, you can take 1, 2. So min step is 0. Is that the only possibility for it to be 0? So we need to say what if min steps is equal to 0, turn false. Otherwise it turn true. Yeah, we can say when S and F overlap, that's actually not true. This shall return T is equal to min steps. When S and F overlap, there is only one way. Right? There is only one way to reach. To go from S to F, and it takes 0 steps. 0 minute. Seconds. Oh, what the hell? What's wrong this time? Huh. 1 1. Huh? What? What the? Isn't this the same? 1? One, 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 one. Wait, hold on. Hold on. 1 1. Start. 1 1. 3. Ha ha. Oh, you can get. Oh. Oh, that is actually true. It depends on the steps. 1 doesn't work because you just. Holy crap. 3 does work. Because you go 1, 2. 2 works. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. Anything will work. It's just 1. It's just one step. Otherwise, it doesn't matter. It's just one, because one, you go out. Oh, hold. So, 2. Minimum steps is 1. Hold on. We need to think again. If minimum step is 1, so like F, S, and F, right? It's like this. Minimum steps are 1. T is 1 work. T is 2, 1, 2. Right? T is 3, 1, 2, 3. Yeah, it's anything will work. Minimum steps 2. I think anything will work as well. That's 2 or 3. Yeah, it's like 1, 2, like it's here and here, right? Or hold on. So if it's this, like we take 1, 2, so we can do 1, 2, 3, right? It always works. It always works. How about this? S and F. That's taking 1 as well. Can you do 1? Can you do 2? 1, 2. Can you do 3? 1, 2, 3. Yeah, it always works. So the only edge case is S and F is the same. Then you do 1. Because you have to move out. And you cannot move back. Huh. Is that so? Okay, so we find the min steps. So basically say if min steps is equal to 0, we shall return t is not equal to 1. Because t is 0 is also fine. Right? We can actually try this. Or can t be even be 0? T can be 0. Alright. 1, 2, 3, 4, 5. As long as it's not equal to 1. Because 2, 3, I think 3 also works. Right? Because 2 works. 1, 2. Right? So 3, 1, 2, 3. 1, 2, 3, 4. Yeah, anything will work. It's just the 1 is weird. Let's see. Is that the one? That is the one. Ah, a little bit tricky. Huh. It is tricky. I mean, it's all right. I think it's an interesting problem. Yeah. Find the minimum steps needed to go from S to F, which and then compare that to T. Now the min steps involve taking as many diagonals as possible. The really tricky part is when S and F overlap and T equal to 1. In such case, it is impossible to go from S to F, right? With one step. Tricky. I can see why people don't like it, but I don't really have too much against this. I think it's fun. I think it's very fun. Yeah, this is the edge case. With height. T larger equal to math.max width and height. Huh, that's different from what I thought. I have width and height, and now plus the difference. So I pick the minimum. Oh yeah, this is the same. This is exactly the same as this one. I just realized. Yeah, I just found the maximum. All right, that's about it. Let's just have some fun. Movement of robots. Some robots are standing on an infinite number line. Oh, with their initial coordinates given by a zero indexed integer array nums, and will start moving once given the command to move. The robots will move a unit distance each second. You are given a string s denoting the direction in which robots will move on command. L means to go to the left and or the negative side. R means to the right. If two robots collide, they will start moving in opposite directions. Return the sum of distances between all the pairs of robots d seconds after the command. Since the sum can be large, we're going to modulo it. For two robots at I and j, pair I and j and pair j and I consider the same pair. Return the sum of distances, between all the pairs of robots. When robots collide, they instantly change direction without wasting any time. Collision happens when two robots share the same place in a moment. For example, if robot is position 0 going to the right and another is 2 going to the left, the next second they will be both at 1 and they will change direction. The first will be in the 0. If a robot is at position 0 going to the right and another is 1 going to the left, the next second the first one will be 0 heading left. Yeah, well, they will meet each other and then they will split. So the command is, so this is very similar to that AND thing, I think. So probably can be solved similarly. So in this case, we have 0, 1, 2. So we have 1 here, 1 here. This is -1, this is -2, and 1 here, right? And the command is right, left, left. So we want to know after 3 seconds, right? I mean, just like the AND problem, once they meet each other, they will immediately swap, which means just as if they have never done so. So we can just say after 3 seconds where this is. Well, after 3 seconds, this will be at 1. Right, so we'll have a 1. This will be -3. And this one will be -1. So we just need to find the distance between all the pairs. Oh, holy crap. How many are we talking about? You're kidding me. 10 to the 5th. And you wanted me to find out the distance between all of them. So we need to find out minus 3, minus 2, minus 1. So it's here, here, 0, and 1. So distance between these two, and these two. Maybe there's a way to compute it faster. There gotta be a way, man. So this 2 is basically, this distance is 2, right? And this distance is 2. And then this distance is 4. So altogether is 8. How do I compute it faster? Like if I have, you know, bunch, I'm gonna say A0, A1, A2, A3, A4. You know what? We might be able to find let's do 3. A0, A1, A2. Yeah, that's no. I want to find the rule. So A0, A1, right? So it's going to be A0 plus A1 plus A0 plus A1. Okay. What if we have this? 0, A1, A2. So it will be A0, A1, A2 plus A0, A1, A1, A2, A0, A1, A2, right? The whole. Did you see anything? Not yet. I don't see anything. Okay, so A0, A1, A2, A3. So we have A0, A1, A2, A3. Okay, two at a time. A0, A1, A1, A2, A2, A3. 3 at a time. A0, A1, A2, A1, A2, A3. 4 at a time. Which means what we have, let's write it here. We have A0, A1, AN, okay, plus A0, A1, A1, A2, A2, A3, AN minus 1, AN, plus A0, A1, A2, A1, A2, A3, A2, A3, A4, AN minus 1, minus 2, minus 1 AN. So I can compute this, or I can compute this. So this, what's this? This is gonna be AN plus A0, AN minus A0. That's not true because these are not the same. But let's call S, okay? Let's call S equal to A0, A1, AN. So this will be A0 plus 2A1, 2A2, 2AN minus 1 plus AN. So that will equal to an S, right? A0 all the way to N plus another S minus A0 minus AN. Right? So 2S minus this. Okay. How about this one? This one, so, A0 happens once. A1 happens 2 times. Right? That will be A0 plus 2A1 plus 3A2. Right? Will be 2A n minus 1 plus an. It'll be like that. Not sure how this one will turn out. Definitely not gonna just do a brute force because you have 10 to the 5th, right? You have 10 to the 5th. So many of them. I am thinking. Notice this is this, and this. It's a 2 at a time, 2 at a time. And then just every single one, you just plus a new one. Every one you plus a new one. Every one you plus a new one. Alright? Every one you plus a new one. So in the start, right, it's going to be S. And then the next one is everybody plus a new one. Right, so it's going to be S plus S. Right, but you're going to minus something. Because A0 plus A1. Right, so A0 plus A1. A1 plus A2. So everybody add 1. But then you need a minus A0 because A0 didn't go, and AN did not participate either. So you minus AN. And after this is going to be this, S plus S minus A0 minus AN. You're going to plus another S, but you're going to need to minus A1, A0. Now this is, you're going to lose track. How do we efficiently find out the distance among everybody? All pairs of robots. All pairs. Alright. Just, all pairs. Maybe, hold on. Can we say, just change the ideas. We have robot 0, robot 1, robot 2, robot 3, and the robot 4. Okay. So all 2 robots 0. So it has 0 to R1, 0 to R2, 0 to R3, 0 to R4. Now this, we can compute just this plus this plus this plus this, right? So now, once we have that, will that help us to compute, let's say, R1 to R2? This, and this. Would it help us knowing the previous one? Well, technically, this is, let's say, I also call this as A0, A1, A2, and A3, right? So this is A0, this is A0 plus A1, A0, A1, A2, A0, A1, A2, A3, okay? So R1, R2 is A1, right? Is A1. Or we can call it R0, R2 minus A0. R1, R3 is R0, R3 minus A0. R1, R4 is R0, R4 minus A0, right? Which means the sum of this, right? If we call S equal to R0, R1 plus R0, R2 plus we can call S0, okay, R0, R3 plus R0, R4. Then S1 is R1, R2, right? R1, R3, R1, R4, which equal to this, so S0 minus R0, R1, that's that, minus 3A0, which equal to S0 minus 4A0, because this one is A0. Okay, now how about S2? Right? S2, we can call it is this plus this, which is this plus this. Right? R1 to R4 minus A1 is this. R1, R3 minus A1. Right? So that will equal to S1 minus R1, R2, right? Because we're doing this plus this. So we minus this, then minus 2 times, because we only have 2, A1, which is S1 minus 3 times A1. That is 2, right? And now S3 shall equal to S2 minus, I'll say, 2 times A2. Does that make sense? So S2 is this and this. So it'll be this and this added together minus A2 hold a second. So what's S2? S2 is this plus this, right? Minus 1 A2, so this one's gone, so it's just this. Minus another A2 is just this. Yep. So what do we learn? What did we learn? We start from S0. Okay, so we compute this, prefix sum. We'll compute it. And once this was done, we know every single one, right? We know that. Then S1 shall equal to S0 minus how many? 1, 2, 3, 4, right? 4 times A0. So this shall be the length. Okay? And then S2 will equal to S1 minus 3 times A1. And S3 will equal to S2 minus 2 times A0. right? 0, 1, 2, 3. I want to give it a shot. Seems to be legit. And yeah. Again, first thing first, you don't need to worry about going left and right. You just pretend this doesn't even happen. So what you do is you go through the string, okay, you add, right? You add d equal to 3. You just add 3, right? Right, it's add 3, right? Just one more time. Just I want to double check one more time. Add 3 minus 3, yeah. This minus 3, add 3, yeah. So we'll have the nums, which just say for int I equal to 0, I smaller than nums dot length I plus plus. The string size shall be the same as, yeah. Then we say if si now dot char at I is equal to left, then nums I will be plus equal to minus equal left minus equal to d, else nums I plus equal to d. Right, so we do this, we handle that. Then we need another one to go the distance. So we say int this will equal to new int nums dot length minus 1. Okay, for int I equal to 0, I smaller than this dot length I plus plus. We say this I shall equal to nums I, that's the position, right? Plus 1 minus nums I. That's the distance between. Right? Is that a distance between? Yeah. Minus 1 minus just 3, right? Minus 1. Yeah. So that's, we get the distance, right? Distance I will be I plus 1. So now we get the distance. Okay, now what we need to do is we need to find s, right? Find s, which is we need a prefix sum. So we need a pre-s 0 and int s is equal to 0. Okay, so what do? For int d of d, I think we can do that. Oh, d of distance, right? So pre-s plus equal to d, right? And s pre equal to prefix sum. So I get a d, s will plus d. Next one, prefix sum, and a new one, we add a prefix sum. So we'll go through that. Is already defined in the scope. Where? I didn't define d before. Oh, my. dd. My bad, I completely forgot about this d. Okay, so we do that. So we got the s, the initial s. Okay, the initial s. And then we'll say int res equal to s. And this might already, so we have to mod it. Okay, we have to mod 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have to mod. Oof, so equal to press plus this mod. And it's the same as plus this mod. And this has to be long. Unfortunately, this has to be long. Okay, so these are all long, which is fine. And this has to be long as well. So we start with S, right? Now we go through the remaining, which will be now this one and this one, right? So what do we say? We say we got S0 basically. So we need to find the next one, which is 1. No, which is starting from 0. Okay. And so we shall say for int I equal to 1, I smaller than yeah 1. We'll go all the way here. This is 2. This is 2. So we go 0. So basically we go from this. Right? We go from this as 1. No. I will start from 0. 0 all the way down to this dot length minus 1 I plus plus. So we don't go to the last one, we go to this one, right? Okay, so new s shall equal to previous s minus something, minus what? Times, so something times this I, right? This I. What is this? This shall be this dot length 4. 1, 2, 3, 4. 4 minus I. Right? That's the first one. Because this is we have to cast too long. I might as well make this long then. Or this dot length. Yeah, we'll just cast it too long. It's okay. Right? Okay, start with this, and now go 1. That's this. I'll go 2. Yeah. Okay, so that looks okay to me. Okay, that looks okay to me. But it's a minus, so what we need to do is this plus mod. Then we need to mod it again. Right? So we do that. Plus mod, then mod. And whenever we do that, we say res equal to res plus s mod. Once we're done, we'll return int res plus mod, just in case. All right, let's see if this one is right. Not sure, but we can definitely try. And let's just do 1. What the hell? It's so wrong. It's so wrong. All right, hold on. I am going to debug this. This is so wrong. Hold a second. Man, this is ridiculous. But it's okay. It's okay. We will debug it. RLL. Let's this one. Some distance. What do we need? Nums, S, and D. Okay, let's debug. Let's put it where? Let's put it here. All right, the distance. The distance is wrong. Dude, what the hell? The distance is wrong. Oh, I think you forgot to sort it. Yeah. So I need to sort here. That's the thing. I forgot to sort. All right, let's run this again. 8. Forgot to sort. Okay, let's try the other test case. All right. Ugh. This is it's hard to say. It's hard to say what went wrong. You know what? I will have to. I honestly have no clue. I could be, you know, it could be, maybe I need to add mod every single time. That's the thing. That's the thing. You never know. But whole, these are int? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, dude. I think I know. I think we have some issues up here as well. Here. Man, are you telling me what I think you're telling me? Dude, this is bonkers. Okay? This is bonkers. Okay, let's not change this. Okay, let's not change this. Let's get a new thing. Long position. How about that? New long nums dot length. Okay. So blah blah blah. This will be long. This will equal to what? Nums I minus D, right? But it's not gonna be correct in a long. Let's position this what equal to this. But we have to mod this stuff. Right? We have to mod it. Even if it's like super negative, we have to mod it. Oh, mod it? No. We don't mod it. Do not mod it. At this position, at this point, I think that's why we go long. So it won't go beyond. 2 times 10 to the 9th. It's fine. It's fine. Right? Because D... 3 times 10 to the 9th. That's okay. Long can handle it. Long can handle it. So we only need to just long it. Right? We just long it. And this is just going to be long. Position will equal to nums I plus D. But we'll long it. And we'll long it. So everything is long. Position is long. Okay. Then we need to sort. That's why I cannot. I have to keep it as is, right? We sort it. And all this will become a position. All these become position. Now, this is a distance. Has to be long as well. Unfortunately, it has to be long. And this is fine. It's just a long value. It's okay, right? And here, this is gonna be long, the long distance. And this is fine, this is fine. I think the rest is okay. We're just changing, right? We're just changing the first thing. Okay, so we need to, oh my goodness. Let's first check these code. Are they right? They are. So now we're gonna put in the ridiculously long stuff. Yep, I think that's it. Huh. Very bad runtime. I wonder why. I wonder why. 24 milliseconds for this thing. Okay, so maybe we can do something about it. Maybe we can, let's say, reduce one of the long. Maybe. And maybe we can also do is, you know, don't add this. Is we have it at the end. I'm actually worried. I mean, I don't need to do this long because this is already long, so it will become long. But what I'm worried is this, with this one, overflow. It's actually likely. It's actually likely to overflow, but we're gonna just try it. It's 24, right? Did we get faster? 17. 17. We did get faster. Yeah, we have the mod here. That's impossible to avoid. We have to do it here. We have to, maybe we can avoid doing it here because it's a minus. No, because this can get huge, right? It gets huge, but it's okay. S is long. So maybe we can get away with this one, not, because it's minus equal to, right? And yeah, let's give this a shot. 16. So this one gets faster. 12 milliseconds. 12 milliseconds. First of all, the collision doesn't matter because it takes no time and it's as if the robots, right? It's as if the robots are as if the robots are just passing each other by. So that's that. Then the problem becomes, and then we can easily obtain the final position, right? Final position of all robots after D. The question now is to find the total distance between all pairs. Now the method here is you can call it prefix sum. Starts with a prefix sum, starts with a sum of all prefix sums, and then progressively compute the distance for each, starting from each robot going to the right. However, it feels slow. Not sure why. O1 login because of the sort. So the only reason that it might get slow, it could be, I don't know, O1 login. It doesn't have a solution, so we have to check. Ends on a plank and prefix sum. Ends trick, let's see. Yeah, you're kidding me. So we figured this one out, right? We figured this out. This is where we didn't figure out. Wait, what does 1L mean? One long. Plus I minus n. We multiply the total number of times that a thing is. Oh, Lord, I think that's actually smart. Hold on. Can we pull it out? So we say, how many times is this one counted? 1, 2, 3, 4. 4 times. Right? We count this one 4 times. Because this counted, this counted, this counted, this counted. After that, A0 is no longer used. And how many this one counted? 1, 2, 3. 1, 2. 1 time. Which means. Oh, yeah, I don't even want to check this one in a moment. This is fine. Oh, I can probably do this. Plus. Right? That's still right? I want this. Okay, so that's that. Sorted. We don't need this. What we need is. Nope. Yep. So what we need is a long rest. Let me just comment out all this. Then we say for int I equal to 0, I smaller than. We have to hit every single one. Oh, we have position. Ah. So smaller than post.length minus 1, I plus plus. And long d. dd equal to 0. Oh, we don't even have to. I just want to initiate it. So dd will equal to position I plus 1 minus position I. then s shall equal to res plus something times dd, and we'll mod it. So what is this something? Depending on how many times this one will get called, right? So how many times? Will be five, right? So position.length minus I minus 1, because position is 5 minus 1. Well, I start with 0, so minus 1 is 4. So we have the 1 time called, 2 time called, 3 time called, 4 time called. So A0, right, is done 4 times. But each time we do it, this one gets called as well. A0 gets called 4 times. How about this? We call 1, 2, 3 times. But here I got caught as well. Right? You should consider that. But we are only considering how many times A0 gets called. Now A0 only gets called. Alright, now A1, how many times A1 gets called? We have 1, 2, 3 times, right? But A1 is also called here, here, and here, right? A1 gets called. Oh, actually, I don't know. This feels like we need more assistance. I count the sum of ai times 1 plus I minus n. It contributes ai, aj minus ai for I plus 1 time 1 j. Hold on. It contributes, so we're looking at each one. So each distance, it contributes n minus I times. There's 1, right? N is 5, 5 minus 1, 4 times. It contributes as ai minus aj when I is smaller than j. That's not right. If ai minus aj, hold on. aj minus ai, right? aj minus ai. This, how many times? I minus 1 time, I plus 1 times. I don't understand. What the hell is j? answer plus equal to I times nums I minus prefix sum. What? That's not even the difference in distance. Alright, index j contribution will be the sum of j minus this plus j minus 1 plus but we know for I smaller than j, nums I smaller than num j, so we can open the ABS as nums j minus nums I. Yeah. So it's j times nums j minus sum see, that makes more sense. That makes more sense. I'll upload this one. With assistance from the computation of the total distance is simplified. Alright, so here's what we're thinking. So we go to the left, we don't go right. It's slightly different. So everything go left will be, you know, this plus this, right? So yeah, I need to write it to help me understand. 0, 1, 2, 3, 4. Okay, so everything ending at here, right? So that will be R1 minus R0. Ending at here will be R2 minus R1 plus R2 minus R0. Here, R3 minus R2 plus R3 minus R1 plus R3 minus R. I know why I was not able to come up with this, because I was thinking in terms of the distance, but you should be thinking in terms of the coordinates. So this is R1 minus R0. This is 2 times R2 minus R1 plus R0. This is 3 times R3 minus R2, R1, R0. So we need a prefix sum, right? And then we need, yeah, think from the perspective of positions, not the distance between positions. Right. Let the robot's final positions be R0, R1, R2. Then all the distances ending at R1 is R1 minus R0. Ending at R2, R2 minus R1 plus R2 minus R0. It's 2 times R2 minus R0 plus R1, ending at R3. 3 times R3 minus R0 plus R1 plus R2. Thus, all we need is a prefix sum of R's. Yeah. Okay, but we have P, we'll call him P, but it's fine, right? We just need a pre-sum, pre-S, right? Okay, so we will go with, this is going to be position 0. From 1 all the way to the end. What do we do? Res equal to res plus position I times position I minus pre-sum. Mod, right? Then pre-sum equal to pre-sum plus position I mod. Is that right? Yep. I think that is the result. Ten. Alrighty. I think we are done with this one. 2731. 2731. Oopsie doozy, that is not right. I should submit both. That's one. Oh shoot, did I not? Thank God. I have both. Oh, this one's not in here. Just make sure it's correct. Yep. All right. That will be it for today. I'll see you guys tomorrow. Adios.